Good afternoon, everybody. In this video, we'll calculate the force of gravitational attraction between Earth and the Sun. So, in the last video, we talked about the Newton's law of gravitation, which gave us an equation to calculate the force between the two masses. So, let's get started. So, the mass of the Sun is this is the mass of the Sun, and this is the mass of the Earth. These are the known values here. The distance between the Earth and the Suns, if this is Sun and this is Earth, so this is the distance from the center to the center. Remember, whenever we measure the distance, it's always measured from the center to center. And that is 150 times 10 to the 6 kilometer. And we need to change this kilometer into meter. How do you do that? So 150 times 10 to the 6, and remember 1 kilometer is 10 to the 3 meter. So if you do your math, it will be 150 times 10 to the 9 meter. Okay, and G, this G is a universal gravitational constant which is always fixed. So memorize this number because it will be same all the time whenever you use Newton's law of gravitation. This value will be exactly the same for all masses between the Earth and the Sun. Whatever the masses is, this will be always exactly the same. So now, by the Newton's law of gravitation, the force of attraction between the two masses is given by this equation. G m1 m2 over r square, and we know the value of G. And just for your sake of understanding, the capital G and the small g are the two different physical quantities. These two are not the same quantities. Remember, these two are not the same quantities. Okay, these two are entirely different. Okay, and we'll talk about that one later on. So this is the formula for calculating the force of gravitational attraction between the two masses. And all we have to do is plug in the values. The G value is here, right over here. So I'm simply plugging in. M1 is the mass of the Sun. So this is the mass of the Sun. So I simply plug in here. And the M2 is the mass of the Earth, so simply plugging in here. And R is the distance. So if you plug in and calculate, you will get this number here. 3.52 times 10 to the 22 Newton. That's the unit of the force. So now if you draw the picture here, the Sun is the Sun and the Earth. The Earth is orbiting around the Sun all the time. Okay, and it takes 365 days for the Earth to complete around the Sun. There must be some force for the Earth to move around the Sun, and that force we call as the centripetal force. And this gravitational force, this humongous force, provides the necessary centripetal force for the Earth to move around the Sun. Without this force, Earth would fly away in a tangential path. So because of this force, Earth is able to move around the Sun. So in other words, this force provides the Earth the necessary centripetal force and keeps the Earth in its orbit. So this is it from this video. If you have any question, any confusion, write to me, and do not forget to like, share and subscribe the channel. Thank you very much.